Welcome back, students. Today's video is going to be about different types of waves, and I'm just going to list a few different types and talk about how they're different. In the last video I mentioned that different waves have different requirements for a medium to travel through, and that is a way that we can distinguish between different types of waves. Okay, so starting off easy here, we'll talk about an ocean wave. Okay, so ocean waves have a medium of water. Obviously oceans are made out of water, and the energy that is moving through those waves has to travel through that water. And I've asked myself, is an ocean wave transverse or longitudinal? I learned in my last video that transverse waves have a propagation that is perpendicular to the oscillations of the wave. And perpendicular just means that they're at 90 degrees from each other. So if the propagation is left and right, the wave is moving left and right, then the oscillations are occurring up and down. And that is the case for an ocean wave, so it's transverse. The next type of wave I want to talk about is a sound wave. Sound does require a medium as well. Whenever we speak to communicate with each other, sound has to be going through the air. But actually, sound can actually travel through waters and solids as well. But traditionally, we can interpret sounds better through air. We've all been in a swimming pool and then yelled under the water and then had someone try to understand us and it doesn't really work. Sound also travels through solids. Whenever you bang a wall or whenever you bounce a basketball on the floor, those sound waves are also traveling through the surrounding solids. So although sound waves do require a medium, they can travel through gas, solids, and liquids. I briefly discussed in the last video how sound waves work, but to sum up how a sound wave works, they vibrate the molecules of the medium that it's traveling through. In the case of a sound wave moving through the air, it vibrates the air molecules in the air and propagates waves outward in a way that the air molecules are oscillating in the same direction that the wave is moving. So for example, if I speak in this direction, the air molecules are vibrating in the same direction, back and forth. They wouldn't be moving this way, they'd be moving the same direction that I'm speaking. As these air molecules vibrate, these kinds of wave patterns appear where there are regions of compression and expansion of those air molecules. This is the same way that sound travels through liquid and solid. It's just that with gas molecules, they're more spread out and they can move more easily. Liquids are in between gas and solid in terms of how tight the molecules are, so sound can travel through liquid a little bit more easily than solids. And then in solids, those vibrations aren't as extreme as they are in a sound wave moving through the air. Okay, we call these types of waves longitudinal waves. The next type of wave we want to talk about is a seismic wave. These are the kinds of waves that occur whenever earthquakes happen. Earthquakes can happen in a few different ways, but they involve the movement of the Earth's crust, and those waves are going to be traveling through the Earth. Seismic waves are a little interesting because they can actually move in different ways. Seismic waves can exist as transverse waves and longitudinal waves. Whenever seismic waves move as longitudinal waves, these are referred to by scientists as P waves or primary waves. Whenever seismic waves move as transverse waves, they're called S waves or secondary waves. Primarily they're going to be moving as longitudinal waves, but occasionally they will move as transverse waves as well. Another wave that I mentioned last time, whenever I was discussing longitudinal waves, was the example of a slinky. And these are called spring waves. And of course, the medium of that spring wave is the spring itself. And as we discussed in the last video, these are longitudinal waves because whenever that spring is compressed and expanded really quick, you'll see that compression and expansion move through the slinky, or move through the spring. The next type of wave I want to talk about is light. Previously, I discussed that light doesn't require a medium, and it can travel actually through empty space. So like in outer space where there's not air, you wouldn't be able to make a sound wave because there's no molecules to vibrate. But light can still pass through that space. Before I get into whether or not light is transverse or longitudinal, another word we use to describe a light wave is called an electromagnetic wave. We will talk about light in more detail later, but in short, light waves are electromagnetic waves, and they consist of a wave of an electric field and a magnetic field cycling between each other, and the cycling of electric field and magnetic field self-propagates the light to keep on moving forever until it reaches something to stop it. Because the oscillations of these electric fields and magnetic fields are occurring perpendicular to the propagation, we call these transverse waves. We classify electromagnetic waves based on what frequency or wavelength that wave has, and we have a whole spectrum dedicated to identifying and classifying what kinds of electromagnetic wave something is, and that's called the electromagnetic spectrum. We'll talk about that tomorrow, but this spectrum includes everything from radio waves, microwaves, visible light, infrared light, to like gamma rays and x-rays and all that stuff. So all those different types of waves are all considered light, and these are transverse waves. The last wave I want to talk about is a gravitational wave. Gravitational waves have actually just been discovered within the past 5 years. We can actually measure the effects of a gravitational wave here on Earth. Gravitational waves that are big enough to measure are oftentimes coming from extreme events like two black holes colliding in our universe. Gravitational waves stretch and compress the medium of space-time itself, and because they are propagating in the same direction that they are oscillating, we can call them longitudinal waves. We aren't going to get too deep into gravitational waves, but I just wanted to mention that that is a thing too. Here's a list of many different types of waves that we'll be discussing, all the different mediums that they move through, and whether or not they're transverse or longitudinal. Thank you guys, hope this video finds you well. Hope to see you next time.